my name's Phoebe Polk. I'm a senior software engineer over at Garden Health, and obligatory Garden Health. We're hiring. If you're looking for a job, check out our career page. We've got lots of engineering positions open, and it's a great place to work. I love working there. So my talk tonight has 3 parts. Basically, part 1 is going to be background. Part 2 is going to be me telling you my tips for building multiple plugins inside a company environment. And part 3 is kind of like a pitch for why you should care, right? Like, so part 1, background. So the background for Pytest is, if you haven't used Pytest, then you've definitely used something similar to Pytest, because Pytest is what's known as a test runner or a unit testing framework. And there are unit testing frameworks in almost every language. There's a list of 82 different languages, and each of them having the list of unit testing frameworks that are used for those languages on Wikipedia, including the ones for Python, which include nose and unit tests and doc tests. These are test runners. There's even a thing for C++ that's called Catch, and Java called JUnit, and JavaScript called Mocha. So, if you haven't used Pytest, you've definitely used something similar to Pytest. So in linguistics, when you see a pattern in a bunch of languages, that there's a common ancestor, so some kind of shared origin point. And so if we look at object-oriented languages, we see that same pattern happening, where there was a common origin point with Kent Beck's Smalltalk. So Kent Beck created Smalltalk, which was kind of an ancestor to object-oriented programming, and that also had a unit testing framework called SUnit. And that is where a lot of the core functionality of unit testing frameworks derives from. What is that core functionality? Well, that's discovering test cases, executing your test cases, and keeping track of and presenting the results to the user. As time has gone by, there has been added additional features to test runners built into these things over time to expand them for new use cases. Some features that are really fun is being able to generate inputs for the test, and also what's known as a fixture, being able to set kind of the preconditions for the testing environment before you run the tests. You can see how that would be super useful, which goes to why Pytest is so much better than everybody else. There's 82 different languages, 2 different hundreds of test runners, but Pytest is different specifically because it has this amazingly modular design. What is a modular design? Well, it's where you have a kind of core set of kind of modules, and then you allow kind of an extension where users install user-created modules, so plugins. And what's great about Pytest, what makes it special and different, is that this modular design wasn't kind of tacked on to Pytest in a later iteration of it. Instead, it is core to the existence of Pytest and how Pytest is set up. So that is really hard for me to tell you about, basically, but a little bit easier for me to show you, right? So I am going to try to show you that really, really quickly. So this is a virtual environment that I have created, and the only thing I've installed is a version of Pytest that I'm super familiar with, Pytest 5.3.5, basically. And Pytest 5.3.5, right, is installed into this virtual environment. I'm really hoping you guys can see this. I'm going to go check the chat to make sure that you guys can see it. Can you see my screen? Somebody say yes. Okay, yes, okay. So when you click on Pytest, like the Pytest module in the site libraries inside your virtual environment, you open it up and there's nothing there. There's no, modules the way that you would normally see modules. And instead you see, like, if you run Pytest main, what it does is it imports Pytest, right? That's weird, right? That's weird. Well, so what happens when you import Pytest is it does this weird thing where it creates a fake module and then it adds all the attributes of that. It discovers all the potential attributes out there and then adds those attributes into this fake module, basically. So that is how it does this magic of being like being modular in its core. So where is all of the actual code for Pytest? It's actually not in the Pytest library. It's actually in this Dunder Pytest library. And if you open up the Dunder Pytest, you're like, oh, look, now I see all of the Pytest things. And then if you look for that module where you set up collect fake module, this is where it is doing that magic, right? Where it's going through and collecting all of these fake modules attributes and setting those attributes equal to the to values on the module that's created on the import. That is mind blown. So exciting. Anyway, so Pytest, if you look at it, it has this Dunder in it, and it goes through kind of like three cycles. When you import it, it does this searching the environment for all of the potential package managers and stuff with Pytest underscore on it, collecting that and adding it into the fake module. Then when you run like pytest.main, it does a thing called Pytest underscore collection. And what Pytest underscore collection does is it searches for what are known as nodes or items inside of the directory structure. Those are your test cases, and adds your test cases into your test loop, which is also known as the test protocol in the naming convention. So then the test loop or test protocol then gets executed by this method Pytest underscore run test loop. And Pytest underscore run test loop has three parts. It has the setup, the call, and the teardown. So that is just to get you familiar with some of the naming and nomenclature of Pytest. So I've kind of already told you about it without actually giving you names, but now I'm going to tell you again the parts of a Pytest plugin are the hooks, which are these methods on the fake Pytest class, following the Pytest underscore naming convention. So those are called hooks, and they have an entire section on the pytest.org about how those work. Then there are fixtures. Fixtures are kind of a flexible class for generating, storing, values to be used in test cases. And then there's like the command line interface or the pytest.ini, which sets all of the settings for the Pytest environment when you run pytest.main. So that's for passing information into Pytest at runtime. So finally, Pytest plugins aren't just aren't just packages or aren't just modules. They're also Python modules. So they belong to a larger class of Python modules. So everything that applies to a Python module also applies to a Pytest plugin. So sometimes you can just write a Pytest module that only has real meaning within the context of your test suite or your test environment, and that's what I call other, right? So it falls into the category of other because it's not specific. It is specific to Pytest, but it's not 100% specific to Pytest. So there are 983 different existing plugins that are available open source on the Pytest website and listed on the Pytest plugin website. And so don't reinvent the wheel. Search first, see if something already exists that has created and met your needs. Some ones that are fun are Pytest emoji. Yeah, there's a lot of good Pytest plugins. So, okay, I have 4 minutes. So I'm going to go through my tips, and then I'm going to keep it short and not actually go too much into the demo world. But tip number 1 is, if you're building a Pytest plugin, use the cookie cutter. Use the cookie cutter. That's step 1. Use the cookie cutter. So Rafael Pierzina has created this cookie cutter, which sets up, right? Which is great because it sets up. You can. What is cookie cutter? Cookie cutter is a templating program that allows you to start a repo or a directory with a certain pattern or pattern. And Rafael Pierzina created this cookie cutter, and it's great. You know, you enter in all of your information, and then voila, you have a beautiful Pytest plugin environment. So, and this doesn't really work for every environment. First off, when you run it, he includes something, an appfair.yaml file. He's got the old school setup for packages, which uses a setup.py, not a pyproject.toml. And he only has like make docs and sync docs available. So that goes to, if you're going to be doing a lot of Pytest plugins in your company, don't just use his, build your own cookie cutter. And that's what I did at my company. I built my own cookie cutter that uses poetry and pyproject.toml, and then also uses very specific versions of Pytest and Python, because that was necessary for my company, basically. But nice thing about his version of the cookie cutter, okay, if I can cd into the cookie cutter, Pytest, yeah, there it is, and then I run talks, is that it comes as a fully functioning Pytest plugin from the jump, basically, and shows you a lot of like the reference that you need to get started with Python, with Pytest plugins. The first of which is this add option, which is part of the command line argument methods. So it allows you to, it shows you how to both to add an option and also add a value to the INI, which goes to my 1.5 tip, which is that the INI will allow you to put strings, integers, arrays, but it will not allow you to put dictionaries into the INI as reference values. So if you have a dictionary, you have to turn it into a JSON and add it as a JSON in your as a string value in your INI. That being said, that's tip 1. Tip 2, right? Okay, I'm over time. Okay, tip number 2 is use Pytester. What is Pytester? Pytester is a great example of exactly what I was talking about earlier with the fixtures, basically. So how fixtures work in tests. So the very first thing you do is you change your Pytest, your conf_test.py, and you set this value Pytest plugins equal to Pytester. And what that allows you to do, what it's actually doing inside the inside Pytest, is that it is normally you have your run test setup, run test call, and run test teardown, basically, that are coming from this runner. But in Pytester, what it does is it replaces that with a test_dir fixture. The test_dir fixture then has an internal method which calls run test setup and run test teardown from inside that test_dir. And that test_dir is a temporary directory where which then acts like the working directory of your Pytest run. So to see that in action, you can look at this example here. So this test_dir gets passed as a fixture into test bar fixture. Then test_dir.make_py file assigns this test file to the temporary directory created by test_dir. And then when you run the method run Pytest, it executes Pytest with the resulting inputs, and then returns a result value. The result value is actually a command line object, basically. So then it has a standard out and a standard error. And it also has an internal assert statement. It only has one assert statement. It should actually have like more assert statements, I think, to be more useful. But the only one it has is this fn match, which goes through and checks the values in a regular expression way, if that value is contained inside your thing. So that's tip number 2. Use Pytester to test your testing, like test your things. And my tip number 3 is that Pytest plugins are packages. Packages should follow good packaging practice. And this is, version control, readmes, docs, doc string coverage, how to contribute page, multiple usage examples, release notes. Use the basics of creating a good package when you are creating a Pytest plugin. Finally, conclusion, why you should care, right? So why you should care is because when you're creating a product, especially a product where the users are going to be developers, it really helps to make it easy to test that product at the same time as it's easy to use the product. So if you think about, like, for example, AWS releases Bodo, but they also release Modo. And Modo is the mocked out version of Bodo, allowing you to build your service around Modo and then transfer it to Bodo. That little courtesy makes your service so much better to use and to interact with, because you're not flying blind. So I actually did this with in my company. I've built Docker. We have Docker containers that run little microservices, and then I also create Pytest. So we have Pytest Docker service, and we have Docker service. And I try to release Pytest Docker service at the same time as Docker service. That allows you to test your service, and then very easily. And it's actually not that much work, because if you're building in a test-driven development way, you are actually building these fixtures in your conf_test.py when you're running your unit tests. And you just transfer your the fixtures in your conf_test into a Pytest package, and now distribute it to everybody. And that makes it really easy for specifically everybody on your team. So like, not everybody's going to be as familiar with your service as you are. And if you don't want to make it like so that people have a learning curve trying to learn how to use your service. So, and then finally, the very popular place to use Pytest plugins is mocking database connections. So I've used a bunch of different resources in giving this talk. One of them is definitely Brian Hawkins' book. There is a brand new version that is completely rewritten and totally modernized and completely worth your $24. So please go buy it if you haven't already, and talk to me about it because it's great. Thank you. Thanks, James. Thanks, Grace. Thanks, Mark.